Personally, I'm interested in shuffle bags.
All right, shuffle bags it is. Actually, shuffle bags are I find it to be a very cool topic. So what is a shuffle bag? Let me get my code up
It's fun
here.
to say.
So shuffle bags are a technique for dealing with random numbers. So let's talk about random numbers. When you're playing a game, let's pretend we're making a card game, and we have in our card game a jack, an ace, a king, and a queen. And we want to present the user with four cards, but we want to give them to them in some arbitrary order, but we want to include one of each card. So what I would like to have done when I click this red button is that you get an ace, jack, king, or queen in some arbitrary order. So if I were trying to do this with random numbers, I might do it like this. I might create a table that has a list, basically, of the four cards: jack, king, queen, ace. And then, down here where I'm drawing the cards, I would randomly select between 1 and the number of cards, which is 4, and pull one of the cards out of the list. So, in other words, select a random number, 1 to 4, use that as the index in the cards, grab the image name, store that here, and then create the card. However, if we run this and we click on the red button a few times, what we're going to see is we're not getting what I want. What I want is one of each card. Instead, I'm getting ace, queen, jack, jack, which is wrong. Preferably, what I would get is each in some random order. So how do we solve this? The easiest way to solve this is to create what's called a shuffle bag. Now, a shuffle bag is a construct where if you what's the game with the letter tiles?
Scrabble?
Scrabble, right. So if you've ever played Scrabble, you've used the physical representation of a shuffle bag. The game of Scrabble has a fixed number of letter tiles. It's always going to have the same number of each letter in all the tiles. So it could have like 3 E's and 4 O's and 2 N's, and there's some kind of random mix, but it's fixed. You get your bag of tiles, and the number of tiles and the number of types of tiles never changes. So what you would like to do is be able to represent that same concept virtually. So in the real game, you reach into the bag. Well, you put all the tiles in the bag, you shake it up. Now they are in some random order. And then you reach in and you take a tile out. And you know when you do this that if there are 3 E's in the bag, you will never get 4 E's when you reach in and pull out tiles. If you get 3 E's, you know you're out of E's. So we do this virtually by creating a mechanism called a shuffle bag. And a shuffle bag is really nothing for Corona. It's nothing more than a table where we can put some entries in, shuffle the table, and then provide a function that allows you to say, give me the next value in the bag. So in our example here, what we're going to do is we're going to put 4 cards into the bag, and then we're going to pull them out one by one. And if we look at main Lua for this example, you will see an example called bag. Go ahead, shoot.
Oh, I was just going to say, I'm assuming then if the algorithm picks a card that already exists, it'll go back around the horn again and try to get another one.
Actually, it's a little bit simpler than that. So what you're talking about is a great approach, okay? So what Charles has said here is said basically, in fact, that's a great intro. So let's back up a minute here. So let's pretend that we have 4 entries. One way we could solve this problem is to create another table and every time we select a card, we put it in let's say file equals file, just to make this easier for me to code up. So what we're going to do here is we're going to select a name of a card out of our cards list, our card table, and as soon as we get one, we're going to put it in here, and we're going to put it in our table in text by the name because we know they're unique. So what we'll get here eventually is we'll have like selected king equals king, and pretend I put PNG on there. The point here is eventually what this table will contain is a reference to each of the 4 cards. So Charles was saying is at this point what we can do is actually this is wrong. All right, live typing. See, Charles, you just can't talk in these shows because then I'm going to try to do it, and it's going to be all very confusing.
That's my job.
Okay, so here's what I've done. Hopefully this runs and doesn't crash. Let's look at the logic briefly. Select a card randomly. We'll get back a string, Jack, King, Queen, or Ace, .png. Immediately go into a loop that says, if that already exists in our selected table, try again. So if we've already selected the ace, select another card. And we keep doing that until this comes back as false or empty. And then immediately what we do is we say selected file is equal to file. And this will totally work. This solves the problem. Charles has solved, you've made it completely unnecessary for me to do this. And
I would like to point out that, if I can interject something, that this would only work if you have unique individual items. If you have, in your Scrabble idea where you have, or in this card game where you have multiple aces, or the Scrabble where you have 3 E's, that doing it this way I don't think would work, would it? Because
you've stolen my thunder.
Oh, okay.
It would not exactly work this way. You could still force it to work. In fact, this is exactly this is why I call this the naive approach. This is not. I'm not pointing at Charles and saying naive. What I am saying is naive is not meant as an insult. What this is meant as is as people approach this problem the first time, they go through these natural steps. They go, okay, this didn't work. How can I make that work? I could look to see if I selected the card. Okay, now it works. No, it doesn't work because I wanted to have 2 E's. How can I do that? I could do a thing where I put the E in a table and then I look at the table. Yeah, that'll work. And eventually they get these like really complicated, naive approaches that work, but are, one, as you said, didn't work initially. This solution doesn't work for duplicate values. You could still make it work. Then the next step is to add variation to make that work, but we still run into another problem. Because this is a naive approach that is not at all efficient, imagine, if you will, you had 1,000 values in your 1,000 unique values, and you were using this approach. You could get into a scenario where you're trying to pick the 1,000th card out of your thing. You know, it's unique. You've got 999. You just want to get that last one. This loop may never end. In theory, it could never end because it could randomly keep selecting 1 through 999, never get the 1,000. Can't even. Should have selected a value I could say out loud. The 1,000th one.